Okay, we just saw before how to apply basketball to solve a maths problem. Okay, now we're gonna apply maths to solve a basketball problem. Okay, so this, would you believe if you have a ring here, right? You have a ring here in the basketball court, right? And you're shooting the ball from here. Okay, you're shooting the ball. Okay, yeah. If the angle, if you shoot the ball from lower than the ring height, which is probably true for everyone except like Kevin Durant or something. Okay, if this angle is less than 30 degrees, okay? So if it's really flat, okay, then the ball cannot swish the ring. Cannot the shot cannot swish. Maybe it maybe can rattle in. It maybe can rattle in, okay, if you're lucky, or like it bounces up and gets in, but it can't swish in. Okay. Does that make sense?
What if the wind pushes?
Yeah, we're assuming there's no wind. We're basically assuming this is just kind of like there's no draft or anything, yeah? Isn't that crazy?
What
Like,
if you like spin it somehow like perfectly? Like
yeah, like the spin could change this a little bit, definitely, because the spin makes it go up a little bit. Okay. Spin's a very interesting effect that we're going to ignore. Okay.
not anymore.
But this is like a simplified model, and it kind of goes to show why you need shot arc to get the ball into the hoop. Okay. So shot arc really helps. Okay. And it's kind of a basic principle. Okay. It's basically, so the thing we need to assume, so we actually know that the width of the basketball, okay, is actually okay. What's wrong with you guys? It's actually half the width of the ring. Okay, you can fit exactly two balls inside the ring.
You can like three.
No. Like along the diameter. Okay, so you need to know that. So the official size of the ball is half the size of the ring. Okay, and you might also know that if you make a right angle triangle, the sine of 30. Okay, so the reason this is 30 angle is significant is because sine of 30 is equal to half. So if you have a right angle triangle, this side is always half as long as that side. Okay? And so what happens is essentially like when the ball is coming in at an angle, okay, um, it doesn't see the full ring, right? It only sees like if the ball is coming in like this, it only like from the ball's point of view, the ring is only like that wide, right? That makes sense? Okay? Because because if you want to swish it, it has to travel in that column, right? Does that make sense? Okay, and then because the angle is 30 degrees, if you shot it at the same height as the ring, the ball will see exactly half of the ring, right? So it'll exactly fit through. Okay. But the problem is you shot it below the height, okay? So that's gonna make it a little bit smaller. Okay, so how do we draw this diagram here? So you have a ring, um, the ball's coming in this way, and it comes in the same angle as it left, right? So the angle going up is the same as the angle going down, okay? Provided that it's from the same height, okay? Can you see that if um if it's a lower height, okay, yeah, that means the ball hasn't had as much time to come down, right? And so the angle is going to be flatter, yeah, because the more it comes down, the more vertical it's going to be, right? Because of the gravity. So the angle is only going to be flatter, okay? So your best situation when you're on the same height, but if it's lower, you're even worse off, okay? So you can actually even calculate the difference when it's lower, okay? And so what does the ball actually see? You know, if that's the horizontal ring, right? And the ball's coming in at 30 degrees, right? Like it only sees um sort of like a column. So let me draw this again. So you have the ring, which is twice. So this is length 2, let's say, right? And you have a ball that's coming in this way. Okay, it's coming in this way. It's making a column. This has length 1, right? And the angle it makes is 30 degrees. And this is 9 degrees. Does that make sense? So the ball is coming in this way, yeah? And because it's 30 degrees, it just has half the length of the hoop. And so it just fits in if it's traveling like that, you see? And so that shows if you shot it any flatter, you're not going to be able to swish it. And if you shot at 30 degrees, you're probably not going to swish it either. Like even if you shoot it like 35 degrees, but you're really short, it's going to not swish. You know what I mean?
But if you're gonna have to shoot like from the 3
Yeah.
line to score.
Yeah, so that's kind of crazy, right? We're using maths to solve a basketball problem. Before we use basketball to solve a maths problem. But obviously it's not symmetric. You're going to use maths to solve basically all the basketball problems. But you can use basketball to solve like one maths problem, okay? Alright, that's pretty cool, don't you think? That was pretty cool.
Yeah, it's very
Very cool. Pretty cool.